x squared plus y squared minus 4x plus 6y equal 87. It says a line has an equation x plus y plus 1 equals 0. Show that the line passes through the center of the circle. Now, to show that the line passes through the center of the circle, then that means that the equation of the line, well, that means we can show this. To show that the line passes through the center of the circle, so what that means is, this is a circle, all right? Let's say this is the center, all right? If a line passes through the center of the circle, it means many things, all right? But most importantly, what it means that is that whatever the point is at the center, that point will satisfy the equation of the line. So the point right here will satisfy the equation of the line. So that's one way of showing that the line passes through the center of the circle. All right, so we just need to show that the equation of the, we need to show that the center, whatever the center is, it will satisfy the equation of the line. All right, so let's do that. So first and foremost, I'm going to rewrite this as x squared minus 4x. We're going to rewrite it as x squared minus 4x. I'm just grouping the x terms plus y squared plus 6y, and that's equal to 87. By grouping them like this, it is easy for us to find the equation of the center, the equation of the circle in standard form, because now we can complete the square to say that this part becomes x minus 2 all square, and we subtract 2 square, which is subtracting 4, plus we complete the square for the two y terms to get y plus 3 square, and then we subtract 3 square, which is subtracting 9, and that's equal to 87. Now, as you can clearly see, if we were to put this in its actual standard form, the equation of the circle in reality is actually x minus 2 all square plus y plus 3 all square is equal to 100. Because minus 4 minus 7 is minus 13, and when we bring over minus 13, that's just equal to 100. All right, so now we have the center of the circle and the radius. All right, we have the center of the circle and the radius. All right, so now we can tell them that the center of the circle is 2, negative 3. That's the center of the circle, 2, negative 3. So now we can answer the question. So if the line passes through the center of the circle, then the coordinates of the center satisfies the equation of the line. All right, so let's test it out. The equation of the line is x plus y plus x plus y plus 1 equals 0. So let's test it out. Let's test out if that is true. Let's test out if that is true. So that implies when we substitute x as 2 plus y as minus 3 plus 1, it's equal to 0. So yes. So we can conclude, yes, the line passes through the center. So the line does pass through the center of the circle. So we're finished with that now. Nice and easy. Now let's look at the second part. It says, find the equation of the tangent to the circle at the point A, which is negative 6, 3. Now we know the center, and we said that the center is, I like to have a sketch. The sketch is always good. All right, so looking at this, this is the point 2, negative 3. 2, negative 3. So if this is 2, negative 3, all right, so our x value to negative 3. So an x value of minus 6, let me put it in green. If this is 2, then minus 6 is over here. And then positive 3 would be here. So based on my sketch, then right here is where the point A is. A is somewhere right here. All right. A is somewhere right here. And then this is the tangent. All right. This is the tangent. I don't need to find the equation of this tangent right here. So now the only way we can find the equation of the tangent is the normal has to come into play. What is the normal? The normal is a line that's going to be perpendicular to the tangent line. All right, the normal is perpendicular to the tangent, and the normal passes through the point A, and it also passes through the center of the circle. So this is the normal. I'm going to use N for normal and T for tangent. All right, so first we need to find is the gradient of the normal. All right, so let's do that somewhere up here. The gradient of the normal is going to be equal to the y value at N, the y value at A, and the y value at A is 3, y2 minus y1, y1 is negative 3, so it's 3 minus negative 3, y2 minus y1 over x2, which is minus 6, x2 minus x1. All right, so it's y2 minus y1 over x2 minus x1. All right, and so what are we getting for the gradient of the normal? The gradient of the normal is 3 minus 3 is 6. That works out to be 6 over minus 8. So if the gradient of the normal is 6 over minus 8, which is really minus 3 over 4, then the gradient of the tangent is 4 over 3. All right, as you can see from this graph or sketch is accurate, the gradient is 4 over 3. So let's write that down then. So yes, so the gradient of the tangent is equal to 4 over 3. And so what's going to be the equation of the tangent? The equation of the tangent then is going to be, so let me write part 2, just so we know. The equation of the tangent is going to be y minus yp, and the y value is going to be 3, so it's y minus 3 is equal to the gradient of the tangent of 4 over 3 into multiplied by x minus 6. So I can just write x plus 6. Now, depending on the question, they didn't ask us to put it in standard form, so I'm going to leave it at that. So that's the equation of the tangent. If you want, you can put it in standard form, but they didn't ask us to do that. So this is where I would leave it, all right? That's where I would leave it. Just to finish the question, I would say this is the equation of the tangent, all right? I wouldn't be trying to simplify it any further because I didn't say to put it in standard form. So you can stop there if you want. Now the next part, part B, is the vectors part of the question. So we've dealt with the coordinate geometry of the question. Now we're going to be looking at the vectors aspect of it. It says, given OA is equal to A, OB is B, and AP is a half OA. And guys, I don't like that AP being a half OA because they give us OA and they give us OB. I want to know what is OP. So they told us that AP is equal to a half OA. So what they're telling us is that AP is equal to a half A. This is what they're virtually saying. AP is a half A. All right. Now, if AP is a half A, AP is really OP minus OA. OP minus OA is AP. OP minus OA. OP minus OA is AP. And so that's equal to a half A. So now if we add OA to both sides, that will then tell us that OP, vector OP is equal to, now remember OA is just A. So it's a half A plus A. And so vector OP is 3 over 2A. All right, vector OP is 3 over 2A because OA right here, remember OA is just A. Set it on the paper, OA is A. So that's OP, 3 over 2A. So first it says, write what is vector BP. So let's write down vector BP. Vector BP, it's vector of the last minus the vector of the first. So vector BP is OP minus OB. But we already know what is OP. OP, as I said, is 3 over 2A. So we can write that BP is 3 over 2A plus minus OB, and OB is just B. All right, so 3 over 2A minus B. Then the next part of the question says, find the magnitude of vector BP, the second part of the question. So in order to find the magnitude of vector BP, we need to expand out what that is. So vector BP, first and foremost, is just 3 over 2A. So it's 3 over 2A, but vector A is 2, 1. Vector A is 2, 1. So this is really 3 over 2 times 2, 1 minus vector B. And vector B is 3, 2. So when we work that out now, it's going to be now 3 over 2 times 2. That's what? 3 over 2 times 2, that's 3. And then 3 over 2 times 1 is just same 3 over 2. I'm going to write it as 1.5. It's easier for me to do calculations that way. Minus 3, 2. All right. Now 3 minus 3 is 0. And then 1.5 minus 2 is minus a half. And that gives us vector BP. Once you get to here, that's vector BP. So now you can find the norm of vector BP. That's what the sign means. It means norm. The norm of vector BP is going to be equal to the square root of 0 squared plus 0.5 squared. All right, that's how we find vector norms or the magnitude. All right, so when you work this out, 0.5 squared is a quarter. When you square root a quarter, you get back a half. And so the norm of vector BP is a half. That's the length. Nice and easy. Soft. That takes care of question 3. Question 3, no trouble at all. So we did vectors and we did coordinate geometry. Now question 4 is going to include trigonometry. That's going to be question 4. Question 4 will be trigonometry. So let's go ahead and knock ourselves out with trigonometry. So question 4, it's telling us that